Good morning, everyone. Welcome to our topic for physical science entitled Chemical Reactions, Acids, and Bases. So, what are chemical reactions, or what is a chemical reaction? A chemical reaction happens when two or more elements combine to form a new substance. The key word here is a combination of two or more elements that makes a chemical reaction in forming a new substance. So this new substance has a new chemical equation too, just like when we have hydrogen, and if you're gonna combine it with oxygen, that is not in their proper chemical combination now because they combine. So when hydrogen and oxygen combines, they have H2O. So that's water now. That is a complete difference between them because their parent element or their chemical property is so different because both of these two are gas and this H2O is a liquid. You see, so the mixture, the combination of these particular elements defines what their chemical equation is. So a chemical equation is a representation of a chemical reaction. So this representation has two parts, the reactants and the products. So you see here, if we will look at this part here, the numbers before their chemical symbol are the coefficient. They're called the numbers. So the reactants are those elements that combine forming a product. Now let's have the next slide. So the reactants versus the products. The arrow divides this equation in half. The arrow divides it in half. We call this as the before. And we call this as the after, meaning after the reaction. Please remember the arrow. The arrow, it refers to as the reaction. Divides the equation in half. So the reactants are the substances that undergo the change. So these two, the carbon and the oxygen, they are the substances that makes the change. And all things on the left side of the arrow, so this is the left side of the arrow, they are called the what? They are called the reactants. Let's move into the products. Now the products are the new substances that form. They are different from their parent element. They are so much different that because carbon and oxygen, they are not harmful, but carbon dioxide is harmful to humans. You see that? So all things on the right side of the arrow, that's the arrow, anything on the right side of this arrow are called the products. So that's after the arrow is called the products, like this one, carbon dioxide. So now let's ID the reactants and the products. Let's identify the reactants and the products. So before the arrow, they are the reactants. So these are the reactants, these are the products. It's the arrow, they are the reactants, these are the products. Both of them are products because it's after the arrow. So this one and the HCl and sodium hydroxide are also the reactants. After the arrow, all of these two are called the products. Everything that is left side of this arrow are called the reactants, and everything after the arrow are called the products. Make sense? I hope that you understand. It is before the arrow, they are called reactants. After the arrow, they are called the products. So let us explain also and identify what is an endothermic and exothermic reaction. We call them both as a type of reactions. Now, endothermic from the word endo, which means inside, which means the word thermic calls for its reaction. So reaction that absorbs energy from its surrounding is called endothermic. You see here, the heat is being absorbed. The heat is being absorbed by this liquid. So when it absorbs energy, it's called endothermic. And then what happens when it absorbs heat? So it's when the heat is being absorbed, meaning the surrounding is what? Cooler. That's what happens. So how about exothermic? The word exothermic which means exit or out, meaning it releases the energy to the surrounding. This type of reaction, the surrounding becomes warmer. What do you think? Do you have any idea what reaction that releases the energy? Maybe you have an idea. One thing that comes into my mind is a bomb, an explosion. When a bomb explodes, it brings forth heat to the surroundings. And because of this heat from this bomb, from the explosion, it kills all living things in the perimeter. So that's why bomb explosion or any explosion is an exothermic reaction. What are the signs of a chemical reaction? Now, in our discussion today, we just minimize it into 4 signs of a chemical reaction. First, one is a production of a gas, like a fizzing sound or a bubbling sound, like something when we open up our soft drink and then as we open it, it sounds like right? It's the combination of the oxygen gas in the atmosphere that combines to the it combines to the carbonated drink in the can or in the bottle that makes the fizzing sound. There is a reaction between the atmosphere and the liquid which is in the bottle. So let's have number 2, formation of a precipitate. So the formation of a precipitate makes an insoluble solid. Example, when we boil something and this precipitate results in this insoluble insoluble solid. So that's the formation of a precipitate. Sometimes it is being left in the container. So let's have number 3. The energy is released. So that's what I have said a while ago. When light or heat is being produced, it's from an explosion, or when you light something or ignition where energy is released, that is a sign of a chemical reaction. And the 4th one is we have a color change, like this one. Colors are changing. One thing also is your food. When you slice an apple and then it changes the color, or the nail, it rusts, so there's a change of color, so that's a chemical reaction. These are the 4 signs of a chemical reaction: production of a gas, formation of precipitate, energy is released like heat or light, and color changes. And this next one is about counting atoms. Now, how do we count atoms? Is very simple. Let's just analyze this first. Before we proceed to our example. Now, counting atoms is so simple. We have to the number in front of the atom is called a coefficient. Let's say, for example, I have here 2 NaCl, meaning I have 2 sodium chloride molecule. So that the number 2 here is the coefficient. 2 is the coefficient. What is that? A number in front of the molecule or the chemical symbol. Coefficients are multiplied to all elements behind it. Meaning, if I have 2 here, I'm going to multiply to the 1 atom of sodium. So I have here 2 for sodium, and multiply it into 2 molecule to the 1 molecule of chlorine. Why is it 1? Because there is no number here, which is considered always as 1. So just like here, we have an invisible 1 with sodium also. So we have 2 and 2 of chlorine. So we have here 2 also. 2 times 1 and 2 times 1. So we have subscripts go to what they just follow. So subscript will go to what they just follow. So the subscript from 1 and 2 from the outside, which is the coefficient multiplied. So what follows is the 2 in here. Now let's move on for another example, a set of example. Now, how do we count the atoms for this as a practice? So it's so simple. Let's have 2 here. Now, because you see there is no number here for carbon, so it has an invisible 1. So we multiply with 2 to the 1 of carbon. So how many carbon do we have now? So that we will write there the C. We have 2 times 1, carbon is 2. So how about oxygen? We have oxygen now, and oxygen has 2 here, so multiplied 2 times 2. Oxygen we have 4. That is so simple. So we will write all of the elements. So we have here magnesium, we have here oxygen, we have here hydrogen. So we have here magnesium. Let's put here oxygen, and let's put here hydrogen. So because there is no 1 here, that means it's an invisible 1. So how many magnesium do we have? So let's have 1 magnesium only, because there is nothing there, no number in there. So that means that is just considered as 1 because there is no number in here. So meaning it has only invisible 1 here. So magnesium has 1. So how about oxygen and hydrogen? Now you see there is a 2 outside the parentheses. So it means you are going to have a distributive property to the elements inside the parentheses. So you distribute that 1 and to hydrogen and oxygen. So we have oxygen first. So we have 2 times 1 of oxygen, we have 2. 2 times 1 of hydrogen, we have 2. So how about here, number 3? So this is very simple also. We have here Ca for calcium. So we have 3 outside, so multiply to the inside. We have 3 times 1 of calcium, we have 3. Now, here is the interesting part in here, because for nitrogen and oxygen, we have here 2 for the outside the parentheses, and we have also 3 as a coefficient. Now, let me introduce it to you. How are we going to answer? First, we're going to multiply first the parentheses. So let's multiply the parentheses first from the outside to the inside. So we have multiply nitrogen. So 2 and 1 of nitrogen, the answer is 2, right? That is 2, but is this final? No, that is not final because we have 3 outside. So we have 2, the answer is 2 times 1, we have 2, times 3, we have what? We have 6. That is 6. How about the oxygen? We have 3 times 2, we have 6, and then times 3 equals 18. So we have 18 for oxygen. Let's have the last one for number 4. Now you see here there is no number outside, so it will be taken as is. So how many elements are there for number 4? So we have 1. How many elements are there in this molecule? We have 1, we have 2, and we have 3 elements. We have nitrogen, we have hydrogen, and we have oxygen. So how many nitrogen do we have? 1. It's so simple because you can see it there. So we have 4 of hydrogen and another 1 for hydrogen. So we have 5. Why did we not multiply that 1? Because there is no what? There is no parenthesis and no outside number. So let's just add. So 4 plus 1, it will be 5. So please do not be confused with that. So we just add the two hydrogen. One that has 4, the other has 1. So how many oxygen do we have? We have just 1. So that is so simple. So I hope you understand my discussion today. Thank you for listening.